This is part 2 of determining the name, Lewis structure, polarity, and intermolecular forces of attraction for NCl3. In this section, we'll discuss how to draw the Lewis structure for NCl3. The first step is to identify how many bonds each element wants or is allowed. If it had hydrogen, we would need to keep in mind that hydrogen has only one electron to share, and therefore hydrogen makes only one bond, never two or more bonds to hydrogen. If it had boron, who is in group 3A, boron has 3 valence electrons to share, so boron is allowed 3 bonds. If you are in a more advanced course, please note that this is not including coordinate covalent compounds. Other nonmetals and metalloids want an octet of valence electrons. Their number of bonds that they want is equal to 8 minus the group number. Again, with advanced learners, note that this video is not going to discuss expanded octets. With NCl3, nitrogen is in group 5A on the periodic table. The number of bonds nitrogen wants is equal to 8 minus 5, or 3 bonds. Chlorine is in group 7A. The number of bonds chlorine wants is 8 minus 7, or 1 bond. The second step is to place element or elements that want the most bonds in the center. In this video, we're just dealing with one central atom, the nitrogen. You can see a different video for what to do when you have 2 central atoms, such as with C2H4. The third step is to draw one line between the central atom and each outer atom. This line represents a single bond with 2 shared electrons. Each atom shares 1 valence electron in the covalent bond. I've put nitrogen in the center because he wants the most bonds, and each chlorine on the outside with the 1 bond that they want. In step 4, if 2 neighboring elements each want another bond, you should give it to them. That's how you would form double and triple bonds. In this case with NCl3, the nitrogen has 3 bonds, so he's all set with what he wants. Each chlorine has 1 bond, so they're happy with the 1 bond that they want. In step 5, draw additional non-bonding valence electrons in pairs around the element symbol. The group number minus the number of bonds will equal the number of dots that you should draw for the valence electrons. These are the electrons that are not shared in the covalent bonds. Pairs of the dots are known as lone pairs of electrons. Nitrogen is in group 5A, so he has 5 valence electrons. If we subtract the 3 electrons that he shared in those 3 bonds, there will be 2 dots, 2 valence electrons that haven't been shared in a bond that need to be drawn on nitrogen. Chlorine is in group 7A. 7 minus 1 bond for each of our chlorines leaves 6 dots that need to be drawn around each chlorine atom. When the dots are added, you end up with a molecule that has this Lewis structure. Note how the dots are drawn like a picture frame going around the atom symbols. So it's done more like a rectangle than some sort of expanding drawing of dots. Also note how each of the atoms has 8 valence electrons if we include the 2 electrons shared in each bond. So we'll come back over here. Each of the chlorines has 6 dots around them, plus the 2 that are in the bonds that they share, and so that adds up to 6 plus 2 is 8. The nitrogen has 2, 4, 6, 7, 8 electrons around it as well, which gives it a stable octet of valence electrons.